Good day class, this is physics special. I'm teaching you projectile motion. So without wasting much of your time, let's see how we can do this as quick as possible. Let's start straight with projectile motion. Now, projectile motion is the motion of an object projected upward at an angle into the air under the influence of gravity, or moving under the influence of gravity. I repeat, projectile motion is the motion of an object projected upward at an angle into the air under the influence of gravity. Let me say that one more time. Projectile motion is the motion of an object projected upward at an angle into the air under the influence of gravity. Alright, now that is for projectile motion. So for those of you writing, it will must have been shown on your screen already. You must have seen it on your screen. Let me draw a diagram to explain and describe the motion of a projectile. Are you getting me now? The motion of a projectile. Let me draw a diagram to explain it. So let me draw a diagram to explain the motion of a projectile. Now we have something like this. Sorry. We have something like this. H. There's arrow. We have Vy here, we have Vx here, and we have Vy and Vx. Alright. Yeah. Now this is the diagram for it. Now let's start explaining with this. Now let's enter some basic concepts of what? Projectile motion. Now we have basic concept of projectile motion. This basic concept is what you are going to use to answer so many questions. So let your ears be open and listen attentively. Some basic concepts of projectile motion. Let me just write that here. Concepts of projectile motion. Open your ear. Open your ears well, because this is what you are going to use to solve problems in projectile motion. Now, the first one is time of flight. Number one, time of flight. Alright. This is the time it takes a projectile. Yeah, now this is the time it takes a projectile to move from its place of projection. It's going to be shown on your screen. To move from its place of projection, that is here, to its maximum height, that is here. I repeat, this is the time it takes a projectile to move from its plane of projection to its what? Maximum height. That is for this one. And the formula to solve for time of flight, open your ears. The formula is what? U sine theta over g. The formula for this number one, that is for time of flight, is what? U sine theta over g. What did I say in the beginning? That time of flight is the time it takes an object to move from its plane of projection to its what? Maximum height. To its maximum height. Alright, number two. Number two is total time of flight. Time of flight. Total time of flight. Now, total time of flight is the time it takes an object to move from its plane of projection to its maximum height and back to the plane of projection and back to its starting point and back to this place. Are you getting me? The time it takes a projectile to move from its place of projection to its maximum height, which is here, then come back to the place of projection or to its starting point of projection. Are you getting me here now? And the formula for this is what? Big T is equals to 2t. There's something I did not write here. U sine theta is what? It's supposed to be what? T is equals to U sine theta, not just U sine theta. So number one, I made a mistake. It's supposed to be T is equals to U sine theta. Now, look, T is equals to 2 big T is equals to 2 small t. Now, what is small t? U sine theta over G. Now, we have gotten something. Remember that I told you that total time of flight is the time it takes an object to move from its plane of projection to its maximum height and back to the starting point or back to its plane of projection. Are you getting me now? Alright, now they said the formula is 2 small t. Now what is small t? U sine theta over G. So the formula will now be, you break the formula down to get your final formula, which will be what? Big T is equals to U sine theta over G. Now that is your formula. Are you getting me now? Are you ready? Alright, the next one is what? Maximum height. Let me clean some place in the board. Maximum height. Alright, maximum height. Alright, number 3, maximum height. Alright, maximum height. Now I've explained this. Now maximum height, this is your maximum height. Maximum height is the highest height. It is where, when you throw an object, the point it reach before it start coming down is your maximum height. See, the maximum height is the highest height of your projection. The place, the center of your projection, where it gets to. Like now, if I throw a pen or a stone to kill a bird, it will go like this. Maybe this is the tree. Now I throw stone from here. The height that it got to before it start coming down is your what? Maximum height. Alright, now this is the highest height of your this is the highest height of a projectile. Now, it's the highest height. It is the height that your object reach before it start coming down. Alright. Now, the formula for maximum height is what? Put your head. U, okay, are you getting me? Sine theta square. U sine square theta square over 2g. Now this is your formula. This is the formula for maximum height. This is the formula for what? Maximum height. Alright, let me use it for the next one. Open your ears. Okay? Fourth one is what? Range. Now, there's something you must know. From here to here is what? Your time of flight. From here to here and come back is what? Your total time of flight. Then this center is what? Your maximum height. The center is what? Your maximum height. Now, where will be your range? That's the question you should be asking yourself. Your range is the ground distance. Is this distance? The distance. Now, it took you this distance to get to this place. So this ground distance here is your what? Your range. So this is your range. And the formula to solving this is what? U sine 2 theta over what? G. U sine 2 theta over G. U sine 2 theta over G. Now, one last thing. Under this range, there's something called maximum range. Alright. Physics students, are you getting me? Are you understanding me? Now, there is something called what? Maximum range. Alright. Maximum range is what? Now, there is something. See javelin, they call it again. Like you throw like this. I think it's javelin. Like when you throw it like this, there's a way you should hold your hand. Yeah, your hand should be at what? 40 degree. So if your hand is at 40 degree, the maximum range to throw an object should be at 40 degree. Now let's use this to get our maximum range. Right. I gave you this formula, u sine 2 theta. It's supposed to be u square sine 2 theta over G. Now maximum range. Maximum range. Maximum range. A maximum range is 45 or degree. Maximum range is 45 degree. Now, your theta, when you want to start solving for maximum range, because when you're about to throw a javelin, your hand needs to be at 45 degree to throw a good throw. So if your hand is at 45 degree, so the maximum range from here to start is what? 45 degree. Before you, the way your hand is supposed to be is what? 45 degree. Alright. We have this theta will change to 45 sine 2 times 45 over G. Now 2 times 45 will give us what? 90. So u sine 90 over G. We are almost done. And sine 90 is what? 1. So if sine 90 is 1, we can just say u 2 sine bracket 1 over G. You can do it like this. Or the answer will be what? U square over G. So this is your formula for what? Maximum range. This is the formula for maximum range. So this is it for projectile motion. In my next class, I will give you calculation in projectile motion. I still remains one of the best in physics, chemistry, and mathematics. High and Moses. So God bless you all and have a nice day.